Well, good afternoon, everybody. I'm John Holdren, Assistant to the President for Science and Technology and Director of the White House Office of Science and Technology Policy. And it's my pleasure to welcome you all to this event in celebration of data to knowledge to action. Before we really get started, I want to take a moment to express for myself and for President Obama a huge measure of thanks to the dedicated team that has made this event today possible. Our colleagues at the National Science Foundation, including Farnham Jahanian, Susie Iacono, and Fen Zhao, our friends at the Networking and Information Technology Research and Development Program, George Strawn and others, Nick Maynard from the Office of Science and Technology Policy, all of those folks and more, and I apologize for not mentioning everybody, have worked incredibly hard to catalyze the collaborations that we'll be talking about today. I think many of you will remember our first White House Big Data event in the spring of 2012. At that one, a number of agencies together committed more than $200 million to launch the administration's Big Data initiative. I said at that time that our fast-growing capacity to harness big data had vast potential to increase U.S. economic productivity, accelerate the pace of scientific discovery, and help address major societal challenges, including health care, climate change, and sustainability. Big data, I said, was about to become a big deal. Now, I know that the metric big deal is not the most scientific standard, and I know that my colleagues at NIST, the National Institute of Standards and Technology, don't have a platinum bar or anything sealed in a glass case that is the official iconic measure of big dealness. But nonetheless, I think I can say with confidence that my prediction that big data would become a big deal was, if anything, conservative. It has become a super big deal. And today marks, therefore, in a way, a moving up ceremony of sorts. It's an acknowledgement of accomplishments from the past year and a half, some of which are highlighted in materials distributed here and posted on the OSTP website. But even more exciting, it's the unveiling of a host of new collaborations and partnerships involving corporations, nonprofits, academic institutions, philanthropies, along with government entities on the local, state, and federal levels, all in support of taking big data to a new level of big dealness. The administration is calling this event Data to Knowledge to Action to highlight that the value of big data flows from our ability to derive actionable insights from data. And that's just what the commitments we're announcing today will do. To give you a sense of the kinds of advances we're seeing in this very exciting domain, I want to take just a few minutes to highlight for you some of the newest commitments being announced by federal agencies. One example that I'm personally excited about is a pilot project that will involve a consortium of government entities, non-governmental organizations, academic institutions, industry partners, and others that will explore how biodynamic data sets can be used to predict the pandemic potential of novel and emerging infectious agents. Another example is the American Energy Data Challenge being sponsored by the DOE, which is encouraging the public to use data sets to design and build tools to empower American consumers to use energy more efficiently. I should note that DOE already has a great record when it comes to applying big data to our nation's energy challenges, through, for example, that department's creation last year of a scalable data management analysis and visualization institute that has already applied new climate-related big data techniques to increase the accuracy of seasonal hurricane predictions by more than 25% for peak year storms originating off the continent of Africa. Yet another example comes from NASA and its powerful Earth Exchange, a research collaboration platform through which scientists can explore and analyze large Earth science data sets, run modeling codes, collaborate on projects, and share results. Today, NASA and Amazon Web Services are announcing a new Space Act agreement to prototype that Earth Exchange platform in the cloud, where it will be available to the general public. The National Science Foundation is stepping up to the plate in a number of new ways. Just last month, it sponsored a 5-day interdisciplinary ideas lab where experts in a number of fields work together to generate transformative ideas for using large data sets to enhance the effectiveness of teaching and learning. NSF has also announced a new Frontiers Award to develop technologies based on big data analytics to help improve privacy online. It's investing $25 million in a new interdisciplinary center for brains, minds, and machines led by MIT and Harvard to help build a theory of intelligence that can illuminate the intricate workings of the human brain and also help us build smarter computers. And NSF is continuing to support its core techniques and technologies in Big Data program and its Data Infrastructure Building Blocks program, which together support more than 50 projects at dozens of institutions. The National Institutes of Health is also on board with its BD2K, that is Big Data to Knowledge initiative, which will develop new approaches, standards, tools, and competencies to help scientists make better and smarter use of the big data being generated by the biomedical research community. This initiative will support 6 to 8 centers of excellence that will facilitate wider sharing of data and train biomedical researchers in big data techniques. The National Institute of Standards and Technology has launched a new open working group that is digging into all the ways in which big data differ from conventional data, not just as a matter of philosophy, although our friends at NIST are famously smart when it comes to questions like what does it mean to be big, but rather so that we can design analytical approaches that take the best advantage of data that are certifiably big. And finally, I'll mention the U.S. Geological Survey, which is committed to providing $9 million for a Big Earth Data Initiative in collaboration with the National Oceanic and Atmospheric Administration, NASA, and the U.S. Department of Agriculture. That initiative will build on lessons from the Geological Survey's cross-disciplinary Powell Center for Analysis and Synthesis in order to deepen scientists' understanding of our home planet and how it's changing. In closing, let me emphasize that although I've highlighted here impressive commitments by federal agencies, the big data revolution is much bigger than any government program or set of government programs. Making the most of the opportunities offered by big data will require the involvement of industry, academia, foundations, and nonprofits as well. That's why I'm just delighted that later in the program, my colleague Tom Khalil will be announcing dozens of new partnerships involving more than 90 organizations. This is exactly what President Obama has meant when he has said repeatedly that we need an all-hands-on-deck approach to advance America's research enterprise, spur new waves of innovation, and re-energize our economy. So I congratulate all the players, public and private, who are working together to move us along the spectrum from data to knowledge to action. And I'm pleased at this point to introduce my friend and colleague, Farnam Jahanian, NSF's Assistant Director for Computer and Information Science and Engineering. Farnam.
Thank you very much, Dr. Holdren. Good afternoon, everyone. I'm Assistant Director for Computer Information Science and Engineering at the National Science Foundation. I also serve as co-chair of NITRD, the subcommittee of National Science and Technology Council. I think to this group, I don't need to convince you that today we live in an era of data and information enabled by scientific instruments, large-scale simulations, internet transactions, videos, images, not to mention widespread deployment of embedded sensors. For example, sensors in bridges alert us to emerging stress fractures, for example. In smart grids, they enable efficient management of precious resources. And in the environment, they can detect the earliest signs of geological instability. We find ourselves inundated with data, characterized not only by its enormous volume or the velocity of its generation, but also by its heterogeneity, diversity, and complexity. As data gathers at an ever-increasing rate at all scales and complexities, there are enormous opportunities, as Dr. Holdren mentioned, to harness data, to extract knowledge, to drive discovery and decision-making, to make increasingly accurate predictions, and to gain a deeper understanding of causal relationships based on advanced data analysis. This is what we mean by data to knowledge to action. Others have referred to data as a transformative new currency for science, engineering, education, and commerce. But consider the implication for our nation's discovery and innovation ecosystem for a moment. First, there are profound implications for the economy. We're talking about driving creation of new, essentially, products and services, boosting productivity of businesses, and potentially transforming business models. In fact, according to a recent IDC report, the data technology and services market alone is expected to grow from $3.2 billion in 2010 to almost $17 billion in 2015. The second implication has to do with accelerating the pace of discovery in almost every science and engineering discipline, from biology and chemistry to astronomy and material science, and the list goes on and on. Finally, data analytics has the potential to solve some of the nation's most pressing challenges in healthcare, sustainability, transportation, education, and public safety. We can envision a day when, by integrating biomedical, clinical, scientific data, we can predict the onset of diseases and identify unwanted drug interactions. By accurately predicting natural disasters, such as hurricanes and tornadoes, we can employ life-saving and preventative measures that mitigate their potential impact. By integrating technology-based approaches, such as MOOCs and inverted classrooms, with knowledge from research about how people learn, we can transform formal and informal education. As Dr. Holdren just mentioned, in March of 2012, the federal government launched a Big Data Research and Development Initiative to advance foundational research tools and technologies required to make these possibilities a reality. The NITRD program, and in particular the Big Data Senior Steering Group, provides the framework and mechanisms to coordinate data-related research and development activities across the federal agencies. I want to take a moment to thank the members of the Senior Steering Group for facilitating and furthering the national agenda for data R&D. Also, I want to especially thank the three co-chairs, Susie Iacona, Alan Deary, and George Strawn, for their leadership of this group. And as we just heard, the NITRD agencies have made extraordinary progress over the last 20 months. But harnessing the promise of big data, or data, requires us to seize three outstanding opportunities. First opportunity has to do with catalyzing and nurturing a thriving discovery and innovation ecosystem. This includes not only government investment in research, education, and infrastructure, but also engagement of all of you, foundations and nonprofits, leading-edge universities and research labs, scientists and engineers, of course, a vibrant private sector catalyzed by the American entrepreneurial spirit, and partnership across all sectors, as we will hear about today. Second opportunity has to do with workforce development. We need people with skills to analyze, understand, and make decisions based on data. Another recent report, this one by McKinsey, estimated that by 2018, the United States alone faces a shortage of 140,000 to 190,000 people with analytical expertise, and over 1.5 million managers and analysts with skills to understand and make decisions based on the analysis of big data. There's an enormous opportunity to prepare the next generation for jobs of tomorrow, I should say. Finally, we must develop new technical solutions for elastic and scalable data management, data curation, storage, and sharing that also preserves privacy and confidentiality. And we must also preserve and ensure the responsible use of data to gain new insights and to motivate actions. In closing, what we're witnessing today is that realizing the enormous potential of data requires a bold, comprehensive national effort with engagement of stakeholders from all sectors. These partnerships lay the groundwork for advances that will strengthen the foundation of U.S. competitiveness for decades to come. We look forward to the discoveries and innovations that will result from these collaborations, and want to thank you all for your role in making these partnerships happen. Now it's my pleasure to turn the podium over to my friend Tom Khalil, who I should acknowledge his leadership has catalyzed the Big Data Research and Development Initiative across the entire nation. Thank you very much.
Good afternoon, everyone. Is everyone fired up and ready to go? All right. So what I'm going to be talking about are the dozens of commitments that the individuals and organizations in the audience have been making to really move big data forward. So can I have the next slide? So as President Obama has said repeatedly, the challenges we face today, from saving our planet to ending poverty, are simply too big for government to solve alone. We need all hands on deck. And that's what the commitments that I'm going to be talking about represent. As Dr. Holdren mentioned, the commitments that are coming from companies, from research universities, from nonprofits and foundations. We're going to start off talking about the commitments that are being made in the area of health. There are huge opportunities to both improve health outcomes and lower costs. So for example, the American Society for Clinical Oncology and their partners are launching a project called Cancer Link. Currently, only 3% of patients participate in clinical trials. And ASCO is committed to figuring out what would happen if we could use the data while protecting patient confidentiality, the other 95%. How could we make our healthcare system much more of a learning system and improve the quality of care and accelerate the development of new therapeutics? Novartis, Pfizer, and Eli Lilly are teaming up to develop a platform that will connect patients and researchers and make it easier for patients to find clinical trials that are relevant to them, taking advantage of the work that the VA and other organizations have done on the Blue Button and great work by OSTP and HHS as well. SAP, the Stanford School of Medicine, and the National Center for Tumor Diseases in Heidelberg are using clinical and genomics data to develop personalized medicine. And Stanford is already seeing an improvement of up to 600-fold in terms of computation related to genomics and clinical information. The National Institutes of Health, IBM, Sutter Health, and Geisinger Health Systems are developing and using new data analytics technologies for early detection of heart disease. Rutgers, SUNY, Stony Brook, and BioClinica are developing novel algorithms to evaluate new therapies for liver, spleen, and muscular diseases. One disease that's being looked at, sarcopenia, impacts 45% of the older US population. An organization called Our Health Data Cooperative will help patients better manage their health data while providing it anonymously for clinical research use. The project is open to all US residents, and their goal is to reach 10 million patients by 2016. George Washington University and their partners DCNet and Karen and US Ignite are using next-generation sequencing and high-performance computing to discover biomarkers and new targets for therapies to treat diseases such as cancer. And the Office of Science and Technology Policy is committed to building a coalition of government agencies, universities, NGOs, and companies to improve our ability to predict pandemics. And obviously, the earlier we can predict and identify pandemics, the faster we can intervene and limit mortality and morbidity. MedRed and BT Global are launching an international project aimed at enhancing the integration and dissemination of open health data, starting with a repository of de-identified data from England and Wales. So those are some of the fantastic commitments that are being made in the healthcare area. And there are also some exciting initiatives that are aimed at growing the economy promoting economic growth and job creation. For example, the city of New York, the mayor's office of data analytics is helping new businesses cut red tape and open their doors more rapidly. They've already figured out how to lower the time required to get a license for a new restaurant to 45 days by integrating data from a variety of different sources. The Center for Technology in Government and the Institute for Financial Market Regulation at the University at Albany and SUNY is developing a research agenda to promote the stability, openness, and fairness of financial markets. And this is something that is critically important given the impact that the financial crisis had on economic growth and job loss. In the areas of sustainability, energy, and the environment, as Dr. Holdren mentioned, Amazon Web Services and NASA are making more NASA Earth science data together with analytic tools that were previously only open to NASA researchers. And this is going to enable all sorts of exciting citizen science already with organizations like Zooniverse. We're seeing citizens be able to contribute to important discoveries in the area of astronomy. Google and the World Resources Institute are launching Global Forest Watch 2.0 to provide near real-time information on forests using satellite imagery. And this is also going to include a crowdsourcing capability so that people on the ground can report deforestation in real time. And this is really important for avoiding the climate change impacts and environmental impacts that are associated with deforestation. There is a great collaboration between the San Diego Supercomputer Center, Cleantech San Diego Gas and Electric, and OSIsoft to create a sustainable San Diego. They're developing a data infrastructure that connects the core infrastructure of the city, things like electricity, gas, water, and transportation, to reduce energy and water use and increase the reliability of the grid. There's also a number of fantastic collaborations involving nonprofit organizations. So an organization called DataKind is partnering with Pivotal and Teradata to connect some of industry's top data scientists to nonprofits for pro bono projects for up to 3 months. Some examples of nonprofits that DataKind is working with include The Mission Continues, which provides fellowships to veterans that engage in community service. So DataKind has been involved in putting together 3 ways that data scientists can get involved. A data dive, which is intense work on a problem over a weekend. A data core, which is a pro bono engagement of 1 to 6 months. And a data chapter, which really allows a city or an entire country to get involved in issues related to big data and the impact on society. The Kamasu project is launching a global online living directory to capture every word in all 7,000 languages. So, very modest project. I think they should have that wrapped up by the end of the year. Wish them luck and volunteer. And they're going to be collaborating with the Long Now Foundation, with Global WordNet, with the University of Benghazi, and with the Swiss Federal Institutes of Technology. The Big Data Initiative at MIT's CSAIL, the Computer Science and Artificial Intelligence Lab, is partnering with the city of Boston. They're going to be organizing a series of competitions designed to spur nonprofit and civic uses of data to address real-world problems, and they're going to be starting off with understanding the public transportation patterns in the city as a way of reducing traffic congestion and increasing uptake of public transportation systems. In terms of innovating to increase civic engagement, Splunk, Notice and Comment, which is a small business, the Sunlight Foundation, and regulations.gov are teaming up to improve the government decision-making process, particularly around decision-making around regulations by, for example, providing real-time graphs, dashboards, and visualizations that will make it easier for citizens to see what other people have been commenting and what they've been saying. And we also have a series of commitments that are aimed at improving the core technologies associated with big data. So Berkeley's AMP Lab, which stands for Algorithms, Machines, and People, which is an activity at UC Berkeley that is supported by the NSF Expeditions in Computing Program, the DARPA X-Data Program, and over 21 companies are releasing their Spark software under an open source license. And this is software that makes data analytics fast to run and fast to write. SGI, FedCentric, and the US Postal Service are using analysis of high-velocity data to prevent mail fraud. And a number of organizations are launching the Big Data Top 100 list. This may seem kind of wonky, benchmarking standards, but in fact, objective benchmarks are really important for being able to measure progress and encouraging competition, because in the absence of having third-party objective benchmarks that accurately represent progress, it's difficult to know whether you're moving in the right direction. Finally, there are a number of commitments that are aimed at educating the next generation of data scientists, which is going to be critical to making this effort successful. You're going to be hearing more about this collaboration supported by the Moore Foundation and the Sloan Foundation involving NYU, UC Berkeley, and University of Washington. Stay tuned for that. University of Illinois and the Granger Foundation are developing big data as an engineering discipline. In 2015, University of Illinois will be offering a master's degree related to big data, and importantly is making big data a core class for all of their engineering undergraduates. University of Chicago, with support from the Schmidt Family Foundation, is expanding their Data Science for Social Good Summer Fellowship. This connects undergrads and graduate students with a background in data science to nonprofits and government agencies to help solve problems in areas like healthcare, energy, education, and disaster relief. And IBM has developed an online analytics talent assessment tool that allows students to measure their readiness for all of the data analytics jobs that the companies that are in the room will be creating. And finally, there are a series of commitments that are related to thinking about the ethical, legal, and societal implications of big data. So, for example, a group of researchers, including Dana Boyd, Jeffrey Bowker, Kate Crawford, and Helen Nissenbaum, are creating something called the Council for Big Data Ethics in Society to identify research topics, collaborate with practitioners and policymakers and developers of the technology to explore the societal issues associated with big data. The MIT Big Data Initiative is going to bring together academics, industry, government, and nonprofits to focus on the future of big data and privacy, which is a really important issue, and develop a research roadmap and to look at the privacy issues that are associated with combining large and diverse data sets. Tech America Foundation has hosted a series of big data roadshows this fall in Silicon Valley, where I had the opportunity to speak at Stanford, in Austin, Texas, and Boston, Massachusetts. And they've also developed a public policy agenda associated with big data. So that gives you a sense for the range of commitments that the individuals and organizations here today are making. So I would like everyone to give them a big round of applause for these commitments. So one of the questions that I am interested in asking the audience is really, where do we go from here? And by that, I mean, how can we continue to catalyze and celebrate new and expanded partnerships, both the ones that are being announced today and new ones. How do we share information on the progress that is being made and lessons learned, both the successes and the challenges? And how can we increase the number of organizations that are involved? Because as Dr. Holdren said, the federal government can clearly play an important catalytic effort, but it's going to take government, industry, research universities, civil society, working together to make the most of these new opportunities. Thank you very much. And now it's my pleasure to introduce David Logston with the Tech America Foundation.
Good afternoon, everyone. I'm David Logston, Tech America's Senior Director, Federal Civil Global Public Sector. It is my honor to be here before you today to discuss the progress of big data adoption within the federal government marketplace, as well as the benefits of big data-focused partnerships between the federal government, private industry, academia, and nonprofits. I want to take a moment to thank our sponsor, BAE Systems, for their contribution to today's event. I also want to thank the White House for their leadership in big data and for the opportunity to be part of today's activities. With the evolution of technology comes a need to adapt to such changes. In no place are those changes more apparent than the federal government, which has taken on the challenging transition towards transparency, openness, and innovation. No process, no matter how necessary and beneficial in the long run, is without issues, and a transition involving technology is no different. It is for this reason that the Tech America Foundation established a Federal Big Data Commission in 2012. The Commission's mandate was to demystify the term big data by defining its characteristics, describing the key business outcomes it will serve, and provide a framework for policy discussion. The Commission approached big data from the perspective of key mission imperatives government agencies must address, the challenges and opportunities posed by the explosion in data, and the business and inherent value big data can provide. Big data has the potential to transform government and society itself. Hidden in an immense volume, variety, and velocity of data that is produced today is new information, facts, relationships, indicators, and pointers that either could not be practically discovered in the past or simply did not exist before. This new information, effectively captured, managed, and analyzed, has the power to enhance profoundly the effectiveness of government. Although the impact of big data will be transformational, the path to effectively harnessing it does not require government agencies to start from scratch. Rather, government can build on the capabilities and technologies it already has in place. Success in capturing the transformation lies in leveraging the skills and experiences of our business and mission leaders rather than creating a universal big data architecture. It lies in understanding a specific agency's critical business imperatives and requirements, developing the right questions to ask, understanding the art of the possible, and taking initial steps focused on serving a set of clearly defined use cases. The experiences and value gained in these initial steps lead to more questions, more value, and an evolutionary expansion of big data capability that continually leverages prior investments. As agencies release more and more data sets to employees, other federal agencies, and the general public, we will start to see the true benefit of the data. As this data is pushed to the cloud, accessed mobilely with the requisite security requirements in place, with emerging reliance on social media networks, we will see the convergence of technology trends. Being able to define what that means to federal, state, and local governments is where the future is heading. We at Tech America and the Tech America Foundation stand ready to work with the administration and the federal agencies to help define this landscape. We believe that an additional big data accelerator exists in private-public partnerships that currently exist between the federal government, industry, academia, and nonprofits, a lot of which you've heard about today from Tom. I had the honor of witnessing this work firsthand in our inaugural set of Big Data Roadshows in Austin, Texas, Boston, Massachusetts, and Palo Alto, California. There is an amazing work being conducted at these locations and throughout the United States. Perhaps a handful of regionally located collaboration hubs between industry, academia, and nonprofits could help spotlight this work to even greater degree. Perhaps these collaboration hubs, these regional collaboration hubs, can be located in the South, the West, the Midwest, and the Northeast. We truly believe that this could be a game changer in terms of bringing together all the vested parties that have the institutional knowledge to answer the questions that need to be answered. And perhaps these folks can meet on a quarterly basis. Just a thought for everybody. These partnerships help all parties leverage and build on the existing capabilities to build out big data impacted solutions. These partnerships help make big data a national initiative as opposed to a federal initiative. These partnerships also guide colleges and universities to develop relevant programs, thus increasing the pool of qualified students for big data related roles. Finally, these partnerships promote out-of-the-box, risk-tolerant thinking, traits that have fallen out of favor as of late. I look forward to hearing from our distinguished guests and hope today's event is a step towards building a better technological future for the federal government and for the American public. And I will be emceeing tonight the tech demo night. You heard a lot about these partnerships from Tom. It's one thing hearing somebody speak about these partnerships and the great work that's being conducted. It's yet another thing to see these partnerships in action. And so I encourage everybody to stick around tonight and see this phenomenal work being done. Thank you, Tom. Thank you to the administration, and look forward to our continued partnership.
Okay, so now we're going to hear about a really exciting partnership from two of America's leading foundations and three of America's leading research universities. So please welcome Chris Menzel with the Gordon and Betty Moore Foundation, Josh Greenberg with the Alfred P. Sloan Foundation, Ed Lazowska, Director of the eScience Institute at the University of Washington, Jan LeClun, who's the Director of the Center for Data Science at New York University, and Saul Perot, who is Director of Berkeley Institute for Data Science, Professor at University of California, Berkeley, Senior Scientist, Lawrence Berkeley National Lab, and a Nobel Prize winner. So please come on up.
We've made it. My name is Ed Lazowska. I'm the Bill and Melinda Gates Chair of Computer Science and Engineering at the University of Washington and the Director of the UW eScience Institute. And I'm delighted to be here today with my colleagues from Berkeley, NYU, the Moore Foundation, and the Sloan Foundation to announce a new collaborative initiative in data science supported by a $37.8 million commitment from the two foundations and corresponding commitments from the various universities. This initiative has been in the gestation period for more than a year. The foundation selected 3 university partners 6 months ago, and over the past 6 months, since that time, we've been working together to structure this as a true collaboration. It's an incredibly exciting initiative for all of us, and we're delighted to be able to share it with you and others today. So let me talk a bit about the big data revolution. Of course, all of you in this room are well familiar with it. Exponential improvements in technology and algorithms are creating this revolution. We see a proliferation of sensors. We see the creation of all information in digital form. We see dramatic cost reductions in computation, in storage, dramatic increases in bandwidth, algorithmic breakthroughs in areas such as machine learning. And as you've heard earlier, when we say big data, we don't just mean big in terms of volume. We mean big in terms of velocity, and we mean big in terms of variety. Variety is the complexity, the dimensionality, and honestly, the dirtiness of the data that we have to deal with. So every field of discovery is transitioning from data poor to data rich. The big data revolution is, of course, transforming all aspects of our society. You heard about many of them from Tom Khalil earlier. It's transforming healthcare, it's transforming environmental stewardship, energy, transportation. Our particular focus in this initiative is scientific discovery. And we see this in every field, in astronomy, physics, oceanography, biology, sociology, economics, neuroscience, many more. My longtime friend Jim Gray referred to the 4 paradigms of discovery, as Jim put it. For many, many centuries, science was focused on empirical and experimental work, observing and describing the way the world operated. For the past few hundred years, there's been a theoretical branch to discovery as well, right, based on models and generalizations. 50 years ago, computational science, numerical computational science came along, and it has been hugely transformational. It takes us to places we can't go. It takes us to the instance after the Big Bang. It takes us to tomorrow's weather. Jim observed that we're at the dawn of a 4th paradigm. That 4th paradigm is data-intensive science. So the challenge is to add another V to volume, velocity, and variety. That V is value. The ability to extract knowledge from large, heterogeneous, dirty, noisy data sets, to move from data to knowledge to action, lies at the heart of 21st century discovery. To remain at the forefront, institutions, researchers in all fields have got to have access to state-of-the-art data analysis tools. And these methodologies and tools are going to have to advance rapidly, driven by the needs of scientific discovery. Importantly, data science is driven more by intellectual infrastructure and by software infrastructure, that is, by human capital and by digital capital, than by hardware. So the challenge is to capture the full potential of this data-rich world for discovery, and it's become a real daunting hurdle for domain scientists and for the methodologists alike. Success is going to go to those individuals and groups and organizations that combine domain expertise with computational, statistical, and mathematical skills. Data science is already contributing in many important ways to discovery, but there are systemic challenges that we need to overcome if we're going to maximize its impact. That's the focus of our project. Of course, many other institutions and organizations are involved in this. They are our partners in many ways. We'll build upon each other's work. I think part of what's unique about this collaboration is, first, its scale, and secondly, the fact that it is truly a distributed, collaborative experiment. So we just couldn't be more excited. I'll now introduce my colleague, Saul Perot from Berkeley.
Well, thank you, Ed. So at this point, with all these great advances, one can find oneself wondering, so what more needs to be done? Why aren't we already there? And so I was going to describe a number of the elements that we see as real opportunities to explore with this particular initiative that we think can help in the academic environment, in particular for the science that we're trying to accomplish. To begin with, I think most people who've worked in a university know that there is this standing problem of interdisciplinary reward, which is that if you have somebody, say, who has a strong science expertise, but also a strong computer science expertise, they are therefore less tenurable, less likely to advance in the university setting, because it's hard to evaluate them on either one or the other of their skills. We would like to start exploring ways to make that actually a more valuable and more rewarded role and career path in the universities. We find that as researchers, it's very difficult to find the people that we need to work in the research groups at both the undergraduate, graduate, and then postdoctoral level who have just even the basic data science training that's now standard that you need to approach the data analysis problems of any good research group. And that's obviously silly. I mean, it seems that this is what a university should be good at. We should be able to at least get that basic training available to the undergraduates and the graduate students as they're coming into these at these different levels, so that we aren't using that as a criterion in which we choose who comes to join our research group to do research, but that's just a given, and then we were able to find more depth in our selection. There's a standing problem that I think is very clear when you try to do research, even in the areas of science which are the most advanced in using data science techniques, which is that we are basically constantly in a position of working with shifting sands of personnel who come into program, have a target of a thesis, a paper they have to write, a conference they have to go to, and they get the programming and the data science done to the point that is needed. Then they graduate, move on, and we start over again with the next generation. This is not a progressive field in that sense. It's a little bit like trying to do science before you invented the peer-reviewed journal. And we can do much better than this. It seems to me that there should be ways to make it possible to build on what the previous group members have done, the previous people in the field have done, or even people in other areas at the university or in industry for that matter. So to do that, we would like to explore frameworks and approaches that might make it easier to find what's already out there, first of all, and to find it with good vetting, good evaluations of what's there, what's useful for different purposes at different times. We, on the flip side, also need to make it easier to contribute and to put new ideas and new methodologies, new code out into the world, and have it be well maintained and once more vetted and made available for the next generations within groups or outside in other areas. We've seen, I think, in the years, many of us have been probing since the early 70s, some probably before, and my sense is that the basic feel of what it means to do a data analysis problem hasn't changed that much. There are a few advances here and there, but the basic feel of what it's like to do analysis, I don't think has become much more fluent, much easier than it ever was. And you still, I think the number that's quoted is people spend 80% of their effort in developing, in just managing the data, moving the data around. And it's clear that we could do much better than this to focus the attention of scientists on their science problem rather than on the trivialities and the very messy steps that are necessary just to get your data to the point that you can actually understand what you're doing and to make a plot. So I think there's actually some real interesting areas there to try and think of how to abstract again and ask what would be a better environment to be working in. Clearly, this isn't the problem, as many of the problems we'll be describing, that we expect to solve, but we hope that we at least be able to identify the problem more clearly so as to pose it so that it could be then funded and approached. Now, all this feels like a wonderful opportunity for a university to bring people together. There's ways, these topics are the topics that people share in common across big swaths of the university. And there's this standard problem at a university that you don't really get to hear what's happening across the other side of campus. And we're hoping that actually using this as an opportunity to physically bring people together will allow a much more fertile and exciting period in an academic world. On the more difficult side of bridging gaps, there's this standing problem that what is interesting to the computer scientists doesn't necessarily get down to the level of detail that's needed by the research scientist in approaching a scientific problem. And similarly, what's interesting to the research scientist doesn't necessarily extend through all of the elements of the programming and the computing data science that's needed to accomplish the goals. And so that big dirty middle is often missed, and we clearly need to ways, first of all, to identify the fun, interesting parts of those problems, but even when they're not interesting, they've got to get done, and we should make it possible to do it much more fluently if we can. If we do all of this right, then I think we have a chance to bring new people and new subdisciplines into data science who have not been there before. I think that includes disciplines where it's just not been part of their training and their background to use science to use data science in this way, and I think there's many opportunities across the university for that, and also include some of the underrepresented minorities and women who I think could be much more welcomed into these fields than has been traditionally the case. Many of these fields have actually been very male-dominated in my experience, and I think this might actually be a nice chance to rectify that and to change the model a little bit. Now, everything I'm talking about so far are just the opportunities that we've noticed and identified through just introspection. And I think here, too, we could be a little bit more systematic. We should be actually doing the ethnography necessary to watch what is it that scientists are actually doing, what are research groups doing, and what is holding them up. Where are the slow points? What are the barriers to rapid advance in these data science-rich areas? And I think that many of the things we've discussed will probably come out of that, but I'm hoping there'll be some surprises, and that it'll turn out there are things that we actually haven't caught that could be perhaps low-hanging fruit to allow us to move forward and to speed up the field. So these are some of the opportunities I think that we see, and let me pass on to Jan to discuss how we're talking about approaching it. And introducing Jan LeCun from New York University.
Thank you, Saul. So Saul talked a lot about the problems we're facing, and I'm going to try to talk a little bit about the solutions, or at least the efforts we're going to do to try to overcome those problems. So this is really a deep collaboration between researchers in science on one side and on the methods on the other side. So by the sciences, we mean the physical sciences, life sciences, environmental sciences, neuroscience, as well as social science. Social science is actually a big component of this in the sense that the approach, sort of data-driven approaches to social sciences are on the cusp of perhaps revolutionizing some of the fields of social sciences, as they have in biology, for example. And then on the method side, it's a combination of computer science, statistics, and applied mathematics, and even pure mathematics. So we've had some experience at all three institutions in developing projects that bring together people from those various fields, and we're hoping to define new ways of doing science with this new initiative. The core goals that we are after during this initiative is, of course, sustaining interactions between people in the sciences and the methods and across the sciences. It turns out there are methods that are developed in one context that can be reused in another context. And there's nothing like getting people to meet on a regular basis for sparks to fly between them. So a second very important goal is to establish new data science career paths that are long-term and sustainable. Both Ed and Saul referred to that issue, that there are people who will be essential to this enterprise who currently don't nicely fit in pre-specified or existing slots within academia. So in particular, people who are in between two fields or have joint expertise in the methods and the sciences that Saul referred to already, as well as people who develop tools whose goal is to accelerate the progress of science, and they play a very important role. Their impact is measured by whether the software is used or whether the tool they develop are being disseminated and used, and not necessarily by how many papers they've published. So we have to build an ecosystem of analytical tools that will allow us to share methods as well as software and infrastructure to accelerate the progress of science, at least data-driven science. So there are barriers between those two sides of the equation, if you want. And what we're going to do is try to build bridges or tunnels between the two sides of the methodology and the sciences on the other side. And we're going to organize ourselves in 6 working groups that are each going to try to focus on a particular obstacle that separates the two sides. So those 6 working groups are composed, each of them is composed of 3 to 6 faculty from each university, working together and trying to solve the problem as they show. And this, if you haven't figured it out already, this initiative is more about organizing ourselves than about focusing on particular problems in science. We'll do the science, but really what we are trying to figure out here is how to organize ourselves so that the science goes fast. So let me start with career paths. So this is one of the main problems we're going to have to solve, create sustainable long-term career trajectories for people who are in between fields and people who focus on creating tools, as I mentioned earlier. And this is complicated, of course, by the current way we measure impact in science, which is by publications and not necessarily by how many people download your software and use it. So we have to change those metrics a little bit. So we'll establish the notion of data scientist within universities, as well as what we call data science fellows. So kind of a new category of scientists, if you want, who are in between methodologies and the sciences. A very important component of this is education. So there's a huge gap to fill, which was referred to earlier, on educating data scientists, not just for science, but also for industry. It's very difficult to hire data scientists now if you are in industry. You want to hire people who have both the expertise in computational science, computer science, as well as in the required mathematical and statistical domains, as well as the expertise in the specific domain that you're trying to treat. So what we're going to try to do is create new educational programs that essentially have all three components: the mathematics and statistics on one side, the computation on the other side, and the domain science on the third side. And data science is really at the intersection of all three. This Venn diagram was borrowed from Drew Conway, who is a former PhD student at New York University, who is a political scientist who uses data analysis to derive knowledge from data. And he drew this little diagram that's been running around the web and it's been very popular to explain what the concept of data science is. So all three institutions are going to create educational program as well as boot camps and summer school. At NYU, we've already created a master's program in data science that started this September. And we're looking forward to seeing how well the students will do in the larger world. The second point is software tools and environment. This is a crucial aspect, of course, of progress in data science. How do we accelerate the progress of science by providing the right tools for the scientists so that they spend more time doing the science and less time managing data or writing software? And it's a major issue because software produced by scientists is very often orphaned in the sense that it's very difficult to maintain it in the long run. And so we have to set up organizations with people whose main drive is to provide software that's actually used by other people, not just by themselves. Reproducibility and open science is also a very important aspect of it. We're through software and through practices, we'd like to establish ways to promote open science so that methodologies that are developed within one context are transferred in another from one field to another, from one university to another. And so examples of this would include development of best practices for reproducibility, traceability of data, and building support for that in terms of software. And then another very important aspect is working space. So this is how we would promote interactions between people by co-locating them as much as possible in the same space. Each of our universities are committed to providing dedicated space to data science in different ways. At New York University, in the Center for Data Science, we are putting together a center with, in the long run, we'll have on the order of 20 faculty with our students and postdocs and visitors and scientists and tool developers. Some in the science, some in the methods, all co-located in the same place. Berkeley has the new Institute for Data Science, where again scientists and tool builders and methods people will interact. And University of Washington has a Data Science Studio that plays a very, very similar role. Another aspect of this that we're going to develop across our campus and between our campuses is video wormholes. So this would be ways to promote or enable interactions, spontaneous interactions, where you have a wall that's on, a video wall that's on all the time, and when people show up in a room at a university on the other side of the same wall, you can start talking and interacting. Data science, in a sense, will be the great unifier. People will come together, people from different fields will come together because they have in common the same problem to solve and the same methods that they may use. And then last but not least is trying to figure out how we're doing. Studying what scientists actually do when they engage in data-driven science, and trying to identify the main obstacles so that we can perhaps provide the tools and the organization that would solve the problem and maximize the efficiency of science development. So we are certainly at the dawn of a new era in discovery and learning, the fourth paradigm, as Ed mentioned. And we have to realize that the amount of data that is coming to us is increasing exponentially at a very high speed, correlated with the speed at which our storage systems increase in capacity. And it's a very, very large exponent. The amount of brain power on the planet does not increase at the same speed. It actually increases exponentially, but the exponent is very small. So pretty soon we'll be submerged by data, and it will have to be the case that most of the knowledge in the world will have to be extracted by machines. There's just not enough brain power on the planet to do it. So we have to develop the tools for that. We have to develop the methodologies for this. Everything is to be invented. And this is a challenge that we're up to. We're extremely excited about this opportunity. In fact, what we're trying to do here is really answer big questions, big scientific questions of our time. Questions like that Saul has been working on, for example, what's the universe made of? And a lot of the experiments that people do in physics today essentially rely on analyzing gobs and gobs of data. That's true of certainly cosmology, that's true of high energy physics, the discovery of the Higgs boson. That's true of many domains, and an increasingly large number of domains. What are the mechanisms behind life is a big question, of course. So this is one of the domains where data science has already had a big impact with genomics and bioinformatics. So to some extent is already ahead of the game. Another big scientific question is how does the brain work? And there is a lot of initiatives, government initiatives as well as others to map the brain, map the activity, trying to reproduce brain function in artificial systems, understand the principles behind intelligence. That's one of the big challenges of the next few years. And the last one is perhaps the most challenging, perhaps, in some ways, because of the complexity of the systems we'll be studying, is how do we understand human behavior and societies? And this is where perhaps one of the big revolutions will occur in data science in terms of its application to social science. And I'll call Josh Greenberg.
So I'm Josh Greenberg. I direct the Alfred P. Sloan Foundation's program in digital information technology. I just wanted to say very quickly, underscore two particular things from the presentation today, and things that make this a particularly exciting collaboration from the perspective of a foundation. The first is that a lot of what we do is fund individual projects. We fund advancements in a particular field or in a particular technology, and we came to believe, in collaboration with colleagues at the Moore Foundation and elsewhere, that there also needs to be changes and real attention focused on the institutions in which research happens. That if we don't engage institutions as these three are, then we won't see the true impact of the kinds of funding and the kinds of advancements that we'd like to see. The second point that I'd just like to make is this really underscored, this was a fantastic collaboration, the process with the colleagues at the Moore Foundation through the selection process, and really over the past 6 months, excuse me, where not just at the faculty level, but at the administration level. These three universities have been tremendous partners, committing really remarkable resources. And it's not just the three people here. There are dozens of colleagues at every level of the university who've been participating and helping to shape this. So it's just been very exciting and inclusive to see. Chris.
Great. Hello, my name is Chris Menzel, and I'm the project member, one of the project members in the Moore Foundation that got this project started. And just to follow on what Josh said, this collaboration is really a 5-part collaboration, and something that was born out of a desire to really support the people that are at the heart of data-driven research. These multidisciplinary researchers really are the focus of all of the efforts that we're putting forth over the next 5 years. The Moore Foundation sees supporting these people as a critical barrier in advancing science across many of the basic research domains that the foundation supports. We're tackling this through a data-driven discovery initiative. This institutional partnership is the first step for us, and we plan to announce other efforts, other opportunities in the near future to directly support the people and practices involved in data-driven research. I'd just like to just extend just a personal thanks to my colleagues on the stage. Their personal efforts over the last dozen or so weeks has been just astronomical. So thank you for everybody, all of your help and all of your dedication to data-driven research. And I forgot one thing. We're all very cognizant of all of the other efforts that are out in the world. And particularly in this room, many of the projects and collaborations, centers that agencies, industry, and private and research organizations, we plan to operate with you. We plan to share what we're learning and to practice open science and look forward to collaborating with you all over the next years. So thank you very much.